Hi everyone, welcome to today's edition of our Enterprise Database Migration Lab. For today, we are exploring using Terraform to create a network peering. And before we go in deeper into what Terraform is, or into how we can use Terraform to create a network peering, let's talk a little bit about why we should peer our network, or why we should create a network peering. The idea about creating a network peering is to protect our database. When you want to launch a database, it's good to create a network peering so that you can secure a database and make sure it is only the networks or the users who are supposed to have access that are accessible to the database. So typically, communication services must be set up so the right computers can talk to each other. End users should be able to reach the web servers. The web servers should be able to reach the database servers through peer connections, which we call the VPC. And the admin should also have secure access to the database through the virtual private network or Interconnect. There are various ways how we can network between our computers or between our servers. Three of them majorly: the cloud VPN, dedicated interconnects, and the partner interconnect. For cloud VPN securely connects your on-premise network to your Google Cloud Virtual Private Cloud network. It is useful for low volume data connection because it supports connections up to 3 GB per second. You can create a classic connection VPN which has 99.9% SLA. You can also create the high availability VPN, which is the HAVPN. And the cloud VPN supports site-to-site VPN. It supports static routes, which is the classic VPN. It also supports dynamic routes through the cloud router. And you can have the IKE version 1 and IKE version 2 ciphers. For dedicated interconnect provides direct physical connection between on-premise network and Google server. This enables users to transfer large amount of data between two networks, which can be more cost-effective than purchasing additional bandwidth over the public internet. To use dedicated interconnect, users need to provision a cross connection between the Google network and your own router in a common co-location facility. So there are some co-location facilities. To exchange routes, you have to set up a BGP session over the interconnect between the cloud router and your on-premise router. And this allows user traffic from the on-premise network to reach Google Cloud resources on the VPC network, and also vice versa. Going over to the partner interconnect. The partner interconnect typically provides connectivity between your on-premise network and your VPC network through a supported service provider. It is majorly useful if your data center is in a physical location that can't reach a dedicated interconnect co-location facility, or if your data needs does not warrant a dedicated interconnect. To use partner interconnect, you have to work with a supported service provider to connect your VPC and on-premise network. So there are various supported service providers that you can check in with them under the partners interconnect documentation. Let's go over a brief comparison of our various interconnect options. The first connection, which is the IPsec VPN tunnel, it provides an encrypted tunnel to VPC network through the public internet. It has a capacity of 1.5 to 3 GB per tunnel, and it requires an on-premise VPN gateway. For the dedicated interconnect, it provides a dedicated and direct interconnection to VPC network. It can cover between 10 GB per second to 100 GB per second per link. And for the requirement, it requires a connection in a co-location facility. For the partner interconnect, it requires a dedicated bandwidth connection to VPC network through a service provider, and it has a capacity of 50 MB per second to 10 gigabytes per second per connection. And the requirement is a service provider. You have to have access to a supported service provider. And the access type for all this interconnect option we've mentioned are the internal IP address. So here are some things that you can also take notes when using VPC peering. 1. Peered network can be in the same project or in different projects. Peered network can also be owned by different organizations. Peered VPC network remain administratively separate. Subnetwork IP ranges can't overlap across peered VPC networks. And another one is transitive peering is not supported. So typically, a peering request has to be made from both networks for the connection to happen. Internal IP addresses range in the peered network can't overlap and should not overlap. Routes are automatically generated that allow traffic to flow between the peered network. And in this lab, we are going to show how you can use Terraform to automate the creation of peered network. So to begin our lab, I'm going to start this lab, just as I always do. After starting the lab, then to window. So next, then my password. Next also. I understand this. So it has launched my GCP dashboard. So I'll agree to these terms and service. So an overview of this lab is having multiple networks allow users to easily isolate machines and control which machines have access to other ones. But in this case, database. So users typically want their database to be isolated in their own network with no external IP address. So in the case where you need to connect from an external client, you only want them to be accessible from machines in the same network. So you can put database clients like web servers in another network, then peer the two networks, allowing communication via only internal addresses. So if you want connections between third party or third clients, you can put those clients or those web servers in another network. Then you now peer between two networks over an IP address. So let's get started. The setup and requirements, we've done that. For task 1, we want to peer two networks. And to peer two networks, so this is our project ID. We are going to use the Cloud Shell. So I'm activating my Cloud Shell. And my Cloud Shell is getting activated. It's provisioning my Cloud Shell machine. Thereafter, it will connect to our Cloud Shell instance. Yeah, just got this. So here we are on our Cloud Shell. The first thing we want to do is we want to clone a GitHub repository that include a provision versions of our previous lab. So if you check my previous lab, I'm going to link it on top of your screen. You can see how we went through the process of creating various resources. Since we've done that, we don't want to go over creating those resources again. We can just pull the code that we have from a GitHub repository that contains the completed versions of the previous lab that we've covered in this track or in this playlist. So I'm just going to use a git clone just to clone the repository here. So it's cloning the repository to our Cloud Shell. I'm going to fast forward and see you at the end. Yes, we are done. So the next thing I want to do is want to cd into the folder that we are going to use. And the folder we are majorly concerned with is Terraform create peering. So I'm just going to cd into that folder. So I cd into the folder. Now I'm in the folder. If I want to show the files in this folder, I can just use the ls command, and you can see that we have a whole lot of files in the folder already. 1, 2, 3, 4, 5 over 8 files in the folder. Okay, so the next thing we want to do is we want to open our Cloud Shell editor and see what we have on our Cloud Shell editor. So to open our Cloud Shell editor, from open editor here, I just get this. So let's wait for it to initialize our editor. Hi. So it may take a while to launch the editor. I fast forward it, and here I am. So when you see something like this, you can just open your editor in a new window. When you click on open your editor in a new window, then you have this page here, which is fine. So let's open our terminal back here. So the next thing we want to do is we want to go to these files under this path. So to go to this path from our Cloud Shell, we click on the folder, then after that the courses. So when you have the courses, we have the data analysis. I'm coming, I missed something. Courses, okay, from the courses we have the DB migration. From the DB migration we have the Terraform create pairing. So here we are, and these are the documents that we saw then. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the documents that we typically saw then when we run the ls command on our Cloud Shell. So this ls command that we saw. 5. The 10 files we have here, these are everything on our Cloud Shell. So which is fine. The next thing we want to go to from the instruction is the terraform.tf verse, and under the terraform.tf verse, if you watch the video that I linked previously, you'd see the steps of how we created all this. So I'm just going to change this to my project ID. So I'll copy my project ID from here, then change this part to my project ID. After changing to my project ID, then the next thing I want to do is just initialize Terraform. After initializing it, then plan, then run the Terraform apply auto approve. So I'll save this with Ctrl S, then go back to then I run the Terraform init to initialize Terraform. So our Terraform has been initialized, and you can run the Terraform plan to see how it's going to create these resources. So authorize this. So here are the resources, here are the 13 resources that is going to add. You can take a look at them one by one. The first one being the firewall allow ping is also going to allow the firewall RDP, also going to allow SSH. Also, these are for the private, so the public is going to allow ping, RDP, SSH. Then it's going to create a private test server. It's going to create an instance called private test server Linux. It's going to create another instance that's on this complete instance. It's also going to create a private VPC, a public VPC, a private subnet, a public subnet. Yeah, so these are typically what it's going to create. Then the next thing is to run Terraform apply. So we are going to add a flag auto approve. So you can run it once, and you can see, so it's going to create everything for us. So you can see it has created the random ID. It's still creating. It's going to create the public and private ID. You can take a look at the logs here and see how it's creating all the resources that I mentioned previously. Yes, so it has created all the resources, and in a bit we'll take a look at them on our console so that we can see what has been created. So let's just go to our console and see. Let's go to our computer engine first and see the virtual machines that he has created for us. So this is the private test server Linux, this is the public. If you click into each and every one of them, you just see the properties of it. So this is everything here, and this is the network interface. This is subnetwork. Also created a subnetwork. This is the VPC. If you click on the public also, you also see the information under the public. So this is the boot DX, and this is the network interface. This is the VPC, the public VPC. This is the subnetwork. If you also go to VPC, you would see it also, but let's just take a look at it. When you go to the VPC, you can see we have our private VPC, we have the public VPC. This default is created on any GCP project by default, unless you delete it. So this is our private subnets. I've shown that before. When you click on public also, you'd see your public subnets. So public. If we take a look at the firewall rule, it will show all the firewall we created. These are the firewall for the defaults that comes with the default VPC network that got created. But this is everything that we just created now. The private allow ping, allow RDP, allow SSH. Same thing for the public, allow ping, allow RDP, and allow SSH. Yeah, which is fine, but we tweak some things along the line. Yeah. So the next thing we want to do is we want to copy the internal IP address of the private machine to the clipboard, and it should be this. So it should typically be this, but let's see. Let's copy the internal IP address of our private machine. So our private machine, when we go to our compute engine, our VM instance. So here we are. This is the internal IP address of the private virtual machine instance. Start copying this, we have to ping to this from the public machine. So when we SSH into the public machine, then I would see if I can ping to the internal IP address that I copied. So let's wait for our SSH to get created. Yeah, here we are. So this is the internal IP address. Then I run the ping command. After that, enter. So typically it should not work at the moment. So you can see that it's not working. It's unable to ping to the private from the public. So let's adjust some little things, and you see that it's going to get pinged. So to allow communication between the two GCP over the internal IP address, we have to first pair them together, and that is the main motive of this lab. So let's see how we can pair them. So to pair them, we'll go back to our cloud editor, and from our VPC network pairing. So let's take a look at the VPC network pairing here. When you go to VPC, from our VPC network, then VPC network pairing, you'd see that we do not have any pairing at the moment. So let's create a pair between those two VPC networks, between the private and the public. So to create a pair, we'd go to our cloud editor. This is our cloud editor here. So after going to our cloud editor, so we would create a new file called vpc pairing.tf. So you can create a file in two ways. So you can create a file with this command. What this command is doing is that it's first seeding into the directory. So this is the folder, this Terraform create pairing. This is the folder we want to create this file named vpc pairing.tf. So you can either create it by just running this command or just creating a new file from here. This is the folder here. I can just create a new file in that folder, then I'll name it the vpc pairing.tf. So in that of the ways, and this is my new file here. So the next thing I want to do is I want to paste this following code into the vpc pairing. So this is the code that is going to pair both of them together. And you can see this is the network, the public, the pair network is the private, and from this one, this is the private, the pair network is. So this typically just means from the explanation I made earlier, I said a peering request has to be made from both network, and that is why there are two network peering. So one from the public to the private, and the other from the private to the public. So typically this, just paste it here. Then thereafter would save. So after saving our file also, we can now initiate the Terraform apply auto approve once again, or you can just start from, you can typically start from Terraform. You can still typically start from Terraform plan. So let's see, and you can see it's going to add two things, which is the peering from the public to the private, and also the peering from the private to the public. So that's the two additional things that we are adding. So the next command we need to add is the Terraform apply, then the auto approve flag. So it's going to create the two peering requests, and it's creating them. So immediately get created, I would go back to the SSH, and you would see that it can now connect between one another, because the ping effect is still continuing, still trying to ping. So immediately this thing get added, when I go back to this thing, I'm going to notice that when I go back to this SSH, I'm going to notice that it has started pinging. So you can see it has started pinging in between. So it started pinging in between. So to stop it, I'll just use a Ctrl+C. So I've stopped the pinging. If not, we just keep pinging with it. And over that time, it received 26 and transmitted over 223 packet transmitted. So this is just to show that we've created a connection between both of them. So let's see if we've completed this lab. So we've completed these tasks, which is to peer to network, and I can exit the cloud. I can exit the SSH session here. So that's for peering to network. So to understand this lab very well, you have to take a look at the previous lab, which is using Terraform to connect between networks and firewall. I'm going to link the lab in the description also. So the next thing we want to do for task 2 is to deploy a virtual machine with no external IP. So to deploy a virtual machine with no external IP, when we look at the virtual machines that we've created here, let's go back to our console. From the virtual machine on Compute Engine, going to our virtual machines here, you'd see that each of these virtual machines has an internal and external. So I want to create one without an external IP, because I do not want any connection to happen externally. So I don't need to have an internal IP address for that, just to save cost, or and also to be more secure. So what I'm going to do is, on the command that outputs the network interface, I'm going to comment that out. So when I comment that out, it's not going to be able to create any external IP address. So going to our private test server linux.tf. So on our cloud editor, this private test server linux.tf, when I go into it, I have to comment out this. So when I comment out this, it's not going to be able to create an external IP address. So to comment, I just need to add an hash under it. And likewise, after commenting that out, I'm also going to set a none to the output of creating an external IP address. So in the case where it's supposed to create an external IP, which is here, I'm going to just replace this with a string of none, so that it knows that it's nothing to even output here. So after that, I'm going to save this once again. So, and this is typically just what I did here. So because we do no longer have an external IP address, then we don't need to output any value. So that is why I changed this to none. Then after that, you can go back to our Cloud Shell instance, and we can guess the next thing we want to do to create these resources. We would run the Terraform apply auto approve, but before then, let me run the Terraform plan so that we can see what's going to get created. So when you're on the Terraform plan, and you can see it's not creating any new thing because we are not creating any new thing. What we are just doing is that we are changing the configuration of one, and this is the changing. We are setting this to none. So in the case we're supposed to create the external IP address, it's going to be none. Then after that, I'm going to run the Terraform apply auto approve command. So after running that, it's going to run the necessary configuration, which is what is running here. Let's just wait for it to get finished. Yeah, so it has created the necessary configuration here. The next thing I want to do is let's check if I've completed this task, and you all can see that this task is complete. And let's take a look at our virtual machine and see if there's actually no external IP address there. So let's see. You can see that it's still showing here, but when I refresh it, it's going to go away. So just refreshing it, and you can see this has no external IP address. But that does not mean I cannot still connect to it. I can still connect to it because I've paired the network together. Just to show that I can still connect to it, let me SSH into this. Just going to restart the SSH process. So let me ping the IP address of this. So this is just to show that it's the internal IP address that we are using to connect and not the external IP address. And then I ping to this. You are still going to see that it's receiving connection. This is to show that it's receiving connection. Just going to stop this. And during that time, we transmitted 6 packets and 6 got received. So which is cool. And since we are done with what we want to do, we've created 2 networks and we've paired between 2 networks, and we deployed the virtual machine with no external IP address. So I just need to clean up and destroy the resources. So not here, this command will not run here. I have to run it on my cloud shell. So I can just exit this SSH server. So after exiting, go back to my cloud shell here and run the Terraform destroy auto approve. So it's going to destroy all the resources that I get created just to clean up since I am done. And everything is going to get destroyed, and when it gets destroyed, we would take a look at this and you'd see that you're not going to see anything here again. So let's wait for it to get destroyed, finish. I'm just going to pull this up so I can have more visibility. It's going to take a while to destroy all this, and because it has to destroy everything one by one. And yeah, so that's destroyed all the 15 resources. So let me refresh all this and you see there'll be nothing here. So take a look at it. There's nothing. We do not have any virtual machine again. Let's go to the VPC and you see that it's not we are not going to have any VPC network, and if we have one, it's just probably be the default that comes with every GCP project. So, okay, only the defaults remain here. All the private and public has gotten deleted. The firewall will also would have gotten deleted. This is just the firewall of the default only, and there's no network peering again because I've deleted everything with the Terraform destroy auto approve. So, which is fine, and that's the end of this lab. So, an overview of what we've done. We paired two networks to allow communication between machines in those networks using their internal IP addresses. So this typically just means that database can be deployed on a private network without external IP address, and those databases would only be reachable from the paired network and not from anything outside. So if you want your database to connect to something outside, you can create multiple networks, one for the database and one for the external things you want to connect to the database, then connect both networks together through VPC network pairing. Then both of them can talk to one another to the internal IP address. So this is all for this lab. Thanks for staying through, and if you enjoyed this lab, make sure you smash the like button and comment your thoughts in the comment section. Let me know what you like about this lab. Let me know what additional things we can do, and see you in our next series on migrating enterprise database in Google Cloud. Bye for now.